auto m instance m texture, auto is equivalent to map string, create enter the whole key value pairs, insert the required key using the fast in file, auto key value pair m find file name. If key value pair doesn't equal dot end, yes, return the texture. The second part of the KVP, the texture, return key value pair second, else. Okay, so this is like, the else here is what's important.
Yeah, this is deceptively complex. There's not a lot of code, but it's doing a lot of.
The auto really hides a lot, I guess, from you, because it's using an iterator or whatever the freak.
Yeah.
File name not found, create a new key value pair using the file name. So what they're actually doing is, if we remember, like the sprite v whatever PNG, you're handing that into this. You're legit just saying sprite v.png, and then it goes, okay, auto reference texture m file name. So m file name, what is m here? M is the string we handed in?
Huh?
It's
Or is it
not-
inside the client?
It's not in the class. It's it's the auto M down there.
Okay, auto m.
So
The freak is auto here? It's an iterator.
auto.
I've obfuscated this. In the book, they give you the actual full line of the iteration.
Yeah.
Your auto is hiding so much from you, it's
Yeah.
kind of insane.
Yeah, again,
Okay,
I
here we
would
go.
disagree.
Auto is equivalent to map string texture iterator. This is the line. So you could replace auto with this.
Map string texture.
Iterator. So it's just stepping through them. So in this case, M points to the first position in your, is it a dictionary or key value pair? It's a map.
Yeah.
Well, this is a zombie game. Okay.
This is the zombie. Yeah, we're just looking at how they're handling
Yeah.
textures.
We could spend 30 minutes to an hour talking about just this file alone. It's actually doing some kind of advanced stuff.
Okay.
It's like 41 lines, and yet this is actually
Auto reference
kind of
texture
intense.
equals m file. Hold on. The map is string texture. Okay.
Yeah.
So it's linking a string and a texture, right? So you have a pair, a string and texture. You're handing it the name of your texture. It is taking that and it goes, hey, auto pointer to the texture equals the string of the file name, right? Because m is the beginning.
You knew how to.
So we're linking the texture to the string that we handed it. Then we go texture.load from file, the file name, the string that was handed to us, the v.sprite, whatever it is. Return texture. Auto texture m file name. File name not found, create a new key value pair using file name. Okay, so auto reference texture. This is creating a key value pair. Key value pair.
Yeah.
So it's
So I think I understand what's going on about this one.
okay. You want to give it a go?
Sure.
Because I read through it a couple months ago and I'm spacing on it pretty hard.
So I'm pretty sure I understand what's going on, but we're going to have to break down each piece. So what this code is trying to do, what this class is trying to do, is it's trying to store all of the textures that are needed in the program. So in other words, it's trying to keep track of all the textures that have.
Is that good enough?
So
Well, in this case, let's pretend there's no texture.
exactly.
You're
So-
handing in the first string of your b.png.
Right, so
Well, you're gonna pay me?
track the textures, but in a way where the more you load it grows.
You're 22 an hour?
So it does so.
You're gonna
you-
pay me 22 an hour? 22 hours?
Oh, it's not
Those
focusing.
who are unaware, a map is just, it's, you can kind of think of it like an
I
array.
don't think we can get it to focus.
I do not.
No.
Well, I don't know what this map is doing specifically. A map is just a generic data type. You can implement it with
Because
hash
technically,
table.
you're handing it a string, and that string is linked to the texture.
Right.
So
But you know, again,
it doesn't search through this array trying to match the string, right? The whole point of the map is that it's able to convert.
well, it depends. Again, a map is just a formless data
I think my math teacher saw me.
a number of them. It's very common, but it doesn't have to be happening. Since this is a built-in map that I'm.
They included, it's not right there, hashtag include map.
Yeah, I have a feeling the built-in one's gonna use a hashtag. But it really doesn't matter. The important thing is that it stores key value pairs.
How's that
So,
bother you?
in other words,
Huh?
you have data,
Why?
but instead of accessing the data with like an index, you access it with some key. In this case, it's a string.
Yeah.
So we're storing strings and textures. You give the string, it gives you the texture. You think of the string almost like the keyword that gives you the texture. So what we want our program to do is we have our map. And every time we load a new texture, we want to do two things. First, has it already loaded? If it has, don't load it again. Second, if it hasn't already load it once so that we can find it again, and if we try to call it a second time, it doesn't load again. We're trying to only load in the textures that we need instead of loading the same textures like 10 times. Because you only need each texture once.
Yeah.
So let's say we have, well, in this case, their string key is the file name. They're saying, if you loaded in this file name, you have this texture. You don't need to load it in again. So it's like, b.png or something like that. And that actually loads in the B texture.
Here's the line, texture crosshair equals texture holder get texture. So it's calling the texture holder class function get texture.
Right.
And then it's giving us the graphics crosshair.png. It's giving us the string that is the actual location of the texture.
You guys are like more different on the website.
So this is what we want.
So
This is
it's
what it's trying to
going
accomplish. It's trying to make a map to keep track of all the textures that we've loaded, so that we only load them in once each. So this is what it's trying to do, and importantly, it only wants to create one of these maps. We don't want to have a second map that stores all the same textures again. What we're trying to do is avoid double work at all points in the process. Keep track of what textures have been loaded. If it hasn't been loaded, load it once and never again. Because then you can always just access the ones that already exist.
Yeah, I want to say the reason they're introducing this is because, like, let's say you have 100 zombies or whatever.
Exactly.
You're gonna have to keep doing the texture loading for it.
Right. So the way we're accomplishing this is we're not just making a map. This project uses object-oriented design. So we create a class to manage this thing. And inside that class is where we do the work of making sure that only one of these maps exists.
Yeah, by having a pointer to itself.
So in the class, there's only, this is the entire class thing. The only parts that are important are the parts under private and public.
What is static doing in this area here?
So static, in context of a class, what static means is that this variable or function doesn't belong to objects of the class. So this class is called a texture holder.
So that's why in the texture holder.cbp they're able to set it to null because it's declared as static here. Because
Exactly.
it's set as a private.
So we have texture holder. We can create multiple texture holders. Like you can have texture holder 1 and texture holder under normal class definitions. Then we're going to see how this class actually presents this. But we have like texture holder 1, texture holder 2. If something is not static, then every texture holder we create will have one. So the map, every single one of them will have a map. And the, what's the other non-static thing? The constructor, texture holder,
They're still setting up to
So, since these are non-static, every time we create any texture holder, they get one of these.
Yeah, and
The
we only want
static
one map.
the static things are, you could think of them almost like the non-class, non-object oriented functions. So like the static texture holder MS instance and the static get texture function. They are not, each texture holder doesn't get their own of that. There's just one of those in existence that belongs to the class itself.
Okay, so you can still sort of technically make a static text folder 1, text folder 2,
You could.
but you only have one map, one
Yeah,
guy.
each texture holder gets a map because it's non-static. Each texture holder gets a constructor because it's non-static. But the static things, there's only one and they belong to the class. So you can think of it almost like, you know, we're doing object-oriented design, but making it static makes it not object-oriented. You just have the one function that's just called generally, not the one.
Why are they doing it as a class then if we're not?
The whole reason we're doing this is so we can only ever have one texture object. The whole reason we're doing this is to prevent double work. We don't want to load in a texture twice, which means we have a map to interact with. But how do we prevent ourselves from accidentally creating two maps? Well, we put it in a class. Well, how do we prevent ourselves from accidentally creating two of the classes? That's the next step.
Make them static.
Yeah, not just make them static, but make it so that we can only ever have one. So each texture holder is going to have its own map and texture holder object. But there is, since it's static, the MS instance. So,
That's just the pointer.
yeah, texture holder pointer. MS instance. They chose that S.
I want to say the MS is like denotes stuff, because like, see how it means M? I want to say it's part of their style,
It's not
where
something
if
that's-
they're doing a pointer, they'll usually add like a P in front of it, and then camel paste the name.
So there's only one of these MS instances, not one per texture holder. There is only this one MS instance. And so this is going to be our texture holder. That's how we're going to enforce that there can only ever be. Now, all the work for enforcing that is in the CTP. So starting at the top. So the first thing we do,
So the reason you can do the texture holder pointer,
right, so the reason we can do it here, even though it is private, I believe the reason is because this is the actual function definition file for that class. So it's considered internal.
but is it though? Because like legit, it's outside of the thing, right? It's just like, yeah, we're including assert.8, but why are we able to access MS instance outside of the class? Technically, that's not inside the class, is it?
Private rules for C++. I'm not as familiar with Java. I know with Java why it would allow this. I'm not sure why it is in C++. I have my textbook, I'll look at it.
When it goes texture holder pointer, texture holder MS, so is it
So
creating?
it's not creating anything. It is accessing this MS instance, the MS instance. And it's setting it to, well, basically null. Null pointer is just the pointer version of null. So it's saying, hey, this thing, this one that's in existence, right at the beginning, just make sure it's set up.
Does it even exist yet then? Because like, okay, so when it's static, it's preloaded, right? Because you would think
Yeah,
that the
it's-
pointer doesn't exist until the constructor
Right.
happens.
That would be true if it was non-static.
Yeah.
It would belong only to the
Since it
object.
is static, it's been created
It's-
before the constructor.
Yeah, it's created when the header is created. There's just the one. So it's already in existence, so we're setting it to null.
Yeah, and during the hashtag include texture holder, that's when it's being created.
Then, this is the interesting part. So, this is the constructor. So, every time you create a new texture holder, this function is called. Now, what's interesting is, what they've done here is, this happens every time a texture holder is created. So, again, we can create multiple texture holders. But what they're doing isn't creating multiple texture holders. When you create a texture holder, they just set the texture holder pointer, and there's only ever one place.
Yeah.
So no matter how many texture holder objects you create, there will only ever be one main pointer that the whole.
So assert would actually kick you if you try, it would crash the program if you tried to make the second texture holder.
So yeah, the assert, I'm gonna be honest with you, that's not good programming. Assert is used for debugging. This should not be in the final program.
how would you crash the program if somebody tried to do, I guess,
You-
it's there for debugging
Well,
if they accidentally made
Well,
two
first of
classes.
all, ideally, you would not crash the code. What I would do instead is just say,
Throw an error.
if MS instance is not equal to, oh, sorry, if it is equal to,
If I copy the texture holder when they make it the first time and made a second one, what would happen?
the way it works right now, the program will crash and throw a debugging message.
Will it tell me where the issue is?
Maybe, yeah, I mean, the assert.
Assertion failed,
Assertion failed.
and then it shows the MS, so it's a pretty good debugger, I guess, right?
Yeah, that's the thing, this is great for debugging. This is not how the final program should be. So it's, I guess, assuming that this is, in progress lab, it's just, assert is not used in final products. It is used for testing. Yeah, question?
There, a way it seems like you're trying to make sure there's only one order instance. That's what I remember. I heard there, one of the techniques is, it is singleton design.
Exactly what I'm talking about. So they're doing it not quite right. The way you would do it, true, is to replace the assert statement with this. So this line is the same, but it's surrounded in an if statement. So if the MS instance, the one and only pointer, if it's null pointer. If it is null pointer, that means there is none yet. We create one, we set it. Every single time we try to create a new texture holder instance after this will not be null, so we do not set it. The one and only texture holder has already been created.
Would you, what kind of error would that throw?
This would not throw any error.
I mean, no, when you try to do like what we just did, so if I change assert to your if statement now and try to create a second texture holder class,
It will just not do it.
so, but we wouldn't be able to pinpoint.
Are you gonna do a?
Well, that's the difference between debugging and not debugging. Like, that's the thing. We,
If you were gonna ship it,
Well,
well, the thing is, once this is all running and looking good, you could go back and change assert to the if and not care because it ran fine without.
Yes.
it.
Yes. Well, it's the difference between the way it's supposed to work, where, if you ship out a program, it should not crash, period.
You wouldn't do an else statement in there just to go, hey, your pointer's not null. Just to tell you what the issue is.
I suppose you could, but an error message, it should not be in a shipped program. That's the whole thing. If this was complete, it should, and it should just, don't do it. If somebody makes the mistake, the program catches it and prevents it without telling them. It's clean and user-friendly, not easy to fix. The assert is easy to fix. It tells you immediately, you messed up on this line, fix it. This is the way you would actually done. This is the singleton design pattern. If it doesn't exist, make it. If it already exists, it's already made. You can't replace it.
Yeah, and nothing happens.
So there's only ever the one texture holder. You can try and make new texture holders, but this pointer, there's only one. It is set the first time and never again. That's singleton. You can only ever have the one. So you can only ever have one true texture holder. You can create other texture holder objects, but they can never be this texture holder. This texture holder object will only ever have one map. This one map will keep track to make sure that each texture is only loaded in once. You cannot, without going way out of your way, you cannot repeat unnecessary work. This whole thing is done to be very, you're basically writing code to prevent yourself from making mistakes in the future.
Yeah.
Of course, if you were, if you could see, keep in your mind's eye all thousands upon thousands of lines in this whole program all at once as you're changing them, then yeah, you can prevent yourself from making mistakes. But real people can't see thousands upon thousands, you can't even show them all on screen once. So you write the code to prevent yourself from making a mistake, so that if you try to do redundant work, the redundant work just doesn't happen. It's not like, oh, it's redundant, but it's thrown out. It's not even thrown out, it just doesn't even happen to begin with. So you can make the mistake 1,000 times and it won't even drop the efficiency of your program. That's what they're doing here. They're future-proofing themselves multiple levels deep so that it takes a catastrophic mistake to even cause the slightest inefficiency. That's what's going on here. That's why I said these few lines of code are hiding a lot of complexity. It's a very smart way of going about it, minus the assert. The assert is great for debugging, not for the final program.
So the static creates the pointer before the constructor is even run.
It creates the pointer. It's as if it's not even part of the class. It's just,
It pretty much isn't. Even though it's in the private section, you're able to access it, I feel, outside of the class.
exactly.
I almost want to say you could run that line in main for some reason.
Well, I don't think you can. The whole point is,
Like main has, they include,
in fact, the thing that you're trying to avoid is making any of this visible except for get texture. Get texture should be the only thing that the rest of the program can see.
why is this, like, this feels outside the whole thing.
Let me, 1 second. I have my C++ textbook.
See, slide is right here, right?
It is, it should be, there's 14.
Cook.
Maybe it's 13, I don't know.
Okay, no, it works, so I moved it right here, under the main after declarations.
Okay, so it's in main, doesn't, and it's fine with
Because,
it.
like, we're still including the texture holder H here.
Yeah.
And since it's static, it's already created. And I could access and set it to no pointer before the constructor is called. Right, because if you look right here, here's the thing. See, it's set under private as static. But we're able to access it outside of the class. Before it's even constructed. Right? What is static doing?
I don't, it's not a rule of static, it's one of the rules of private. I'm trying to find where they talk about it in this code. This book. That's something. I don't think static is able to do that.
What's the first part? Texture holder pointer, texture holder MS instance, no pointer. Why is that first part there, the texture holder pointer? Wouldn't it be just texture holder, : MS instance equals no pointer?
No, I showed you the document.
Okay, so we're setting its value.
Is it on the drive?
Right.
Is it on the drive? I'm putting it right now.
there's something going on here. The private is making it not fully accessible. I think we're able to set its value, but I don't think we're able to access its value or change its value after it's been set the first time.
For sure. I'll read it over again, we'll see. I don't think they described it very well.
Something's going on with private there. I'm not sure exactly why. Well, here's the thing. I don't know what's allowing them to do in this class, but if you were to, if it was truly private and you couldn't access it outside of this class, what you would do is in textureholder.h, you would say static texture holder ms instance gets null pointer. You just do it here.
But that's the thing, I think static creates it outside. The pointer of the same type as the class itself, what is it saying?
Oh yeah, because it's the same type of class itself. I'm not sure. There's some interaction here. I don't actually teach object-oriented design in C++. I teach in Java.
Definitely.
So there is a rule. I'm just not sure exactly.
Sounds like that, but we could keep grooving.
But either way, it's set to null initially, and then every time
It's
you
checked.
yeah, and then you can only ever set it to not null the one time. So there's only ever the one texture holder that accesses that pointer, and they're only inside of that. There's only the one map, and inside of that map, you're using basically like a mini database, so that each texture is only ever loaded the one time. The whole point of this is to make sure that you have one distinct set of textures. You can only access that one set of textures, and you never load the same texture twice. So that's what the constructor is doing. All of the other work is being done in the one actual public thing in the class, which is get texture. So get texture should be the only part of this whole process that the rest of the program should be able to access. You create the one texture holder, and then from that point on, you just say get texture.
You only want the one map.
Exactly.
10:30.
So
Or 11.
get texture. So you create the one texture, you can only have the one. You try to create a second texture. Either the assert's in there, the program crashes, or you have the true if statement and it just does nothing. Either way, you've only got the one texture.
11.
Now, what this function is doing is ensuring that you can only ever have each texture loaded once. So, first thing it does is complex. It uses auto. It uses auto ampersand, auto reference. It's
Right.
creating a reference
That's it?
with the auto type. If you're not aware, what the auto type does is it tells the compiler, I don't know what the type of this variable is, you figure it out. It's terrible for programming because we're all sitting here staring at auto like, what the heck is this thing? And we don't know.
Well, that little auto is equivalent to map and texture.
They tell us. So what they should have
It's just type it out.
is just typed it out. The few seconds it takes to
I want to say in the book they did type it out and then changed it to auto.
Yeah.
Just to show you like, hey, you could
Yeah.
shorten it.
what you should do is type it out because that is always better programming.
Yeah, because like when someone comes back over to look at it.
The auto type was created to speed up typing at the cost of making it harder to understand what's going on.
Yeah.
And like, the amount of time that you quote unquote save is the difference between typing AUTO and typing map string texture.
Map string texture reference. So it's pointing to this class's map
So,
the texture has.
so what we're doing is we're creating a new variable m. So we have this m. And what it is being set to is inside of our one and only texture item. It's getting the m underscore textures map. So the map is actually called m underscore textures. So in other words, we're setting our m here to be the one and only m textures. So in other words, m is just our map. That's it. M is the map.
But it's a reference to that.
Yeah, it's a
right?
reference.
Because of the,
But it's a reference to the map, but you can think of it as just being the map. So it is the map. Then, what we're doing is we're saying, okay, we have our map. Now m.find file name. Look inside the map to see, have we already loaded this file before? So in my example here, I already have these two. If I look for b.png, it'll return an actual key value pair, something that already exists. And it's, this auto is equivalent to maps.
So if it's doing an iterator, that'll look through it, and if it doesn't find it, it'll return not m.n. If it doesn't find it, it'll return m.n.
Yes. So, I don't know how. Essentially, what's happening is they're saying, try and, inside the map, try and find the text.
You
that
can
we want.
use, so the iterator is, it'll load in the first position, m.start, that'll be the first position. And it'll look through each one. It's a for loop, pretty much. If it doesn't find it, it'll hit the last one, which is m.n.
Right, so there's not actually, yeah, they're kind of faking it though. There's not actually a for loop going on there.
The iterator is a for loop. Because auto equivalent of map string texture iterator. An iterator is a for loop.
Well, not necessarily. An iterator is used in a for loop. It's
Yeah, but when you do m.find, that is a function call that uses the iterator to loop through the map.
But then the key value pair itself is not an iterator. Like, the thing is, it is a complicated way of saying, they're looking through the map to see if they can find the texture. Exactly what the type of that texture is.
Well, an iterator points, right? It's just pointing to a part of the map,
Presumably, yes.
right? So when you set it up the first time, it should be pointing to the beginning of the map, m.start.
Sure.
Right? Then it'll m.find, I would assume, is a for loop that goes, hey, does this match file name, which is our string?
Yes, but the way they've written it here is they're saying that key value pair, that variable, is the iterator. So they're saying find, and it gives you the iterator. It doesn't give you the thing it found, it gives you the iterator.
The iterator is a pointer to a part of the, so m.start is
Yeah,
a pointer
it's-
to the first part of the map,
It's-
m.end is outside.
It's complicated, is the whole thing. It's a complicated way of essentially saying, look through the map, find the thing that exists. If it does not exist, key value pair will be equal to, no, not equal to.
m.n. If it doesn't exist, key value pair will not equal m.n.
Yes.
If it does not exist, key value pair will equal m.n.
If it does
Exist, return the key value pair, which is a pointer. And it's saying second. So let's say you put in B, so it'll go, okay, well, B's here. We're actually pointing. Iterator will now point to the B, and it's returning second, which is the texture.
Yes, yes. So if it's not equal to m.n, that means we found it, and it will just return the texture. You say get texture, it gives you the texture.
You give it the name of the texture, and it will return the texture if it's loaded into the map.
Exactly. You say find texture b.png, and let's say you already loaded it in, it's right here. It'll go into the map, find it, and return the texture. You
Yeah.
have it in the map, it's returned. You do not load it in, it was already loaded in and saved in the map. But let's say you have another one that you have not loaded in yet. Let's say, I don't know, zombie. I already have zombie. No, I have crosshair. So let's say zombie.png is one of them. And so I want to load in zombie, get texture zombie. It goes into the map, it looks at the map, it tries to find zombie, it's not there. So it is equal to m.n. It never found it. It hit the end of the map and never found it. So then we go into the else statement. It creates a new texture.
Again, the auto thing killing us here.
Yeah, again,
Texture
like I
equals-
said, they saved themselves a fraction of a second not typing out the type.
To ruin our day.
It was like a few keystrokes. Thank goodness they saved the time.
Yeah.
Now we get to sit here
Do it
doing.
at the time, dude.
Yeah, what the hell auto is. So don't use auto. This is a perfect case study for why you should never use auto. It exists for lazy people, bad programmers. So whatever, they tried to load it in. Long story short, They are not able to find it, so they load the texture in, they save it into the map.
Okay, well, so right now, m is equal to m.n is the last point in the map. So m.filename, so the string is equal and then to texture.
So,
Then it takes that texture and load from file name.
yes,
So the texture is now loaded.
yes. So the map is full of unloaded textures. So it's saying, okay, we have a texture that we need loaded in. Load this texture and save it under the name zombie.png. That's what they do.
Texture that load from file name. How is it? So the texture equals m file name. And then the load from file.
Yes.
That seems slightly, like the auto's killing me.
So I believe in this case, auto is actually just,
Create a new key value pair using the file name. Texture, reference, texture, and
it's just
file.
texture.
Okay, so it's created, that's what was stripping me up. So you can create the texture without loading. So it's creating a texture with that file name, and then the texture is being loaded.
Exactly. So technically this textures map is full of unloaded textures.
Yeah, and when they do the texture.load from file, that's the current one right there. that we're
Exactly.
holding.
So let's say we call this again on floor.png. Floor.png does not exist. So it tries to find the map, it fails to find it, so it lands on the end. It's like, okay, we didn't find it. So then it goes in and says, okay, well, at the position of my file name, so floor.png, put that in the map, and wherever you put that, give me the texture at that location, unload the texture at that location, and I'm going to load in the actual texture.
Yeah.
And then also, now that we've loaded it in, we also return it because we're trying to get the texture.
So anytime, I want to say in the program, you're going to load in like, I don't know, 50 zombies. Get texture is going to be called 50 times.
Yep. And so, if you want to get and the thing is, what it's doing is it's making sure that you only ever load each individual texture once.
Yeah.
So in this way, we future-proofed ourselves so that every time we want to load in a zombie, we don't have to know what texture we're going to load in. We just say, give me the texture. If it was already loaded, it's loaded. If it wasn't already loaded, it becomes loaded. And then it will never have to load again.
There you go.
So, all of this work.
So you don't need to know any of this, right? You can just copy this.
Well, I did that. Yeah.
I know it's good to know, obviously,
This is-
but if you're making a game and not a great programmer, you'll be like, yeah, just copy this in and it'll make your textures work.
Yeah, so
Copy a texture holder.
to break this down, this part, like the class part, this is end of 360. This part, the pointer part, the loading and textures and maps, that is midpoint of CISP 400 or 401. The singleton designs pattern, I didn't learn about it until my grad program.
Yeah, 430 and 440 did not cover.
Yeah, it is advanced. So, I mean, it's simple enough. It is like the simplest design pattern. It's easy enough to understand on its own. But I never got my lesson on design patterns until legitimately like one of the last classes of my grad program.
Okay.
So,
Basics first.
yeah, so these are all fairly advanced ways. Long story short, all this does is ensures that we only ever load in each texture once, and it is very simple for us to use. Throughout the entire rest of the program, all you have to do is create your one texture holder. Just make the first one, you never have to make it again. And then just say, get texture. Just get texture this, get texture that, get texture that. You don't have to know if it was already loaded or not. This is doing all the hard part for you. You just say, anytime you want a texture, just say, give me the texture.
Yeah, and the name of texture.
It will figure out whether or not it needs to be loaded.
Yeah.
Go ahead.
So the texture holder will always be available as long as the program is running, so it's not like persistent or anything. When the program dies, the texture holder
Would also
say
go.
that
Yeah.
Yeah, it would need to be created at the start of the program.
Yeah, it's legit the first line in the main, I want to say.
So, yeah, it does need to be created every time you run the program, but only the one time.
So if you look at main here, it's the first thing they do. Here's the instance of texture holder. And then this should be, if it is hashing, it should be stupid quick,
Yep.
right? Because like, hey, when you go, hey, give me B is actually hashed. And it is instantly able to pull up where the texture for B is because of the hashing of map.
Which, again, some part of me is saying their usage of iterator is not ideal, but
Yeah.
whatever. That's,
The idea of the whole class is good. Like some things can be changed to better suit your.
yeah,
style.
I would have written it differently, and unless I read through the whole book and understand that they're trying to do something very specific, I'm pretty sure my gut reaction code to write this would actually be more efficient. Like I don't think they're like overthinking me here. I think they're overthinking themselves.
The assert call you cut.
The assert call is debugging only. Like, it's great that you have it in for testing,
Uh-huh.
but like once you understand what it's doing and you
Yeah.
confirmed that it works, like once we're sure that it works, replace it with.
It's also like an if else with saying, hey, it's already null pointers occupied or whatever.
Yeah, that's basically.
That itself is a lot faster. You're not actually doing a call to assert. It's a if else.
Yeah, and the thing about assert is that an assert statement is always supposed to end the program. It says you found an error, stop immediately. So it's not something you put in the final program. Like,
Yeah, it'll crash.
Yeah,
You don't want to crash the final.
It's for debugging. It is I want to find the errors, and so I'm going to have them hit the brakes no matter where I am as soon as I find them. Not the ideal thing to do. The ideal thing to do is just say, hey, if it exists, make it. If it doesn't exist, do nothing.
Okay. Sorry, this might be a little on topic. Like, you mentioned you did a computer program. What area?
Computer science.
Like what area within computer science? Machine learning, graphics?
I didn't really specify. Computer science.
Back in the day, it's computer science.
You got it. If you do a PhD, you'll have to get specific. But and for a master's program, computer science. I mean, honestly, my master's program was a lot like my bachelor's, just higher level courses. I took a high level graphics class, I took a high level machine learning class, I took to fill out my credits, I took an undergrad video game design course because they let me. I took, of course, all the actual hard courses like theory of programming languages and computer architecture and that kind of stuff. So, but yeah, no specific focus for me.
All right.
Yeah, like I said, what was that, about 45 minutes?
Nice.
45 minutes
Well, we
for,
started pretty late.
Yeah.
But yeah.
it's like 45 minutes for
to one fun class.
for like 50 lines of code.
I was gonna say we do the integration, but I think they're doing questions right now, or there's people doing quizzes, so I think we should probably wait until it gets loud over there. We can do one more thing, or did you want to go up, Alex?
I can go whatever.
We could, let me do a quick walk over another fun thing in here.
Yeah.
In the zombie game,
This is
what they do.
fun if complex.
Okay, so they do this thing called view. View, main view. And then they said 00, 1920, 1080. So what they're doing here is they're making a square pretty much. It's saying 00 is the start, it's going to be 1920 by 1080.
Yeah. So
Right.
they're making a rectangle and it's currently covering the whole screen.
So then they create these mouse world position, mouse screen position, a float that stores X, Y, and a vector 2i that stores the position of the screen. Vector array.
Is that what we were trying to figure out about the crosshairs?
Kind of.
Maybe. Let's see here. Now I'm trying to.
In other words, what they're doing is they have the game, and as you move around, the camera follows you. And so,
Yeah.
well, if the camera follows you, where does the mouse go? Like, the mouse has to also follow your screen. So what I think what it's about to show off is the code that makes it so the mouse knows where you are even if the camera moves. Like, the mouse is always clicking on the right part.
There is a convert. There are technically two screens.
Yeah, exactly. And so it's converting between them so that you don't click here and you see an action happening over here.
Yeah.
Actually, very easy mistake to make when you're working with mouse stuff. You click here and it's like click, 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 even though your mouse looks like it's here. So it's
Okay.
like we have to convert correctly so that where the mouse actually is where it's actually clicking.
Okay, so where is this arena? I want to say arena is what we're
The only reason we have to do that is because we're moving around the camera inside the game world.
Where is this?
Because that's what I believe is going on.
See, yeah, I was.
I wonder if the
over-
people
okay,
who,
in Rect Arena.
who created ping pong ever thought
Render
that-
window. So they do a render window right here. Window resolution X,
It was like-
resolution Y.
They still had to work with like real vacuum tubes. Like they were working, like it wasn't like we weren't even like at arcade machines then. They were literally redirecting electrons onto the screen in order to just draw the lines manually. It wasn't just old school tech, it was primitive school.
Okay, so they make two things here. They do a render window called window, and then they do a view called main view. Splitting, giving us the two screens. Then they do arena. Where's this arena I just saw?
So I created up above, but I didn't think it was actually set.
I think it's in the actual arena thing here. Let's see. Zombie arena or arena H. Create background and create background. I think this is the guy. Zombie arena CPP.
Maybe a function doesn't work.
Wait, is this the main? Are we back to main? I lost. Okay, I'm gonna
You guys
skip
down
down.
to check the V out or?
If it's quiet in there, that means they're doing the integration thing right now, meaning they're trying to solve. So if we walk in, that's like walking into the middle of a test. Once it gets loud, we go. Right? Yeah, there's a, you should have signed up, do you know what I mean?
Yeah, but then I'm not actually part of this college.
It doesn't matter, I think anybody can sign
You
up.
said
Too late.
Too late now, but you could have.
Do it next year.
Mouse wheel position, window.map pixel to chord. This is one of the things. But mainly I'm looking for where they're drawing, and I'll just kind of talk about if I remember how it's done. At some point, they do, where is it? Control, find, set. There it is. Main view dot set center, player dot get center. Right? Do you have the mark? It's still the mark. Yeah. So I'll do it under here. You're drawing two screens. You have the main screen, and then there's a second screen where you're drawing that little grid that you guys play on. Right? Like this. And your player moves around this guy. Right? Let's say the player is here. Right? When it says main view dot set center player get center, it is setting the center of our actual screen to the center of the player. Right? So if our screen is this big, it is setting the other screen to the center of this guy. Right? So what's actually happening is wherever our player is just centering our actual screen on him. So when your mouse is actually right here on the actual screen. Let's say your mouse cursor. I'll move it here so you can see it. Our mouse cursor is right here. Right? Technically that's fine. I'm trying to think of a better way to put it. Let's say our mouse cursor is right above the line here. Right? Not there. Well, on the main screen, we're in the upper right corner, but on the other screen, we're not even there. So we have to convert where our mouse is to where our mouse would be inside this other screen that we have. Oh, no, I'd have to double check.
It's complex.
Yeah, no, I remember going over it, because like, my 400 professor actually used this SFML as a draw engine to do the Mandelbrot project. And we did have, so anytime you click, it would start the drawing of the Mandelbrot or whatever. And you click somewhere else, and it would start doing the drawing. And you would have to do the conversion. I think he used two separate or whatever. But you could zoom in and zoom out, and it doesn't matter how much you zoomed out or zoomed in, Mandelbrot formula would just happen.
Yeah, it's
Yeah. So this is what he is. I think that's a pretty fun time, right? Alex, you want to take over from here?
There's two screens, but only one of them is actually rendered.
So.
No.
So think of it like this, Mr. Marker. I think I can draw it. So we have our actual screen. This is the computer screen. It can't move, it's the monitor. But inside the game, we have the play field and the player somewhere inside of it. And so what we want to do is make sure that whatever we see on our screen is always centered. We don't want the player to just walk off and can't see him. In this case, we want the camera to follow the player. So we have our actual screen, the monitor, we can't change this. And then we have the moving rectangle that's following the player and drawing that on the screen.
Let's say,
So what we're doing
She's
is,
gonna,
this is our,
she's gonna try to get someone from her.
I mean,
from her
maybe it make more sense now. The other way around.
I had this great idea of moving the paper around.
So like, we have this big field
Yeah,
and
she's gonna look
players
at it.
over here. We want to draw the screen around the player. But then the player moves over to here. We want to draw the screen around the player. So we have the actual world, that like the whole actual level that's being loaded in, and then we have this rectangle following the player around, choosing what's to actually show on the screen.
The center of the screen will always be the player, right? So you have the whole screen,
Yeah. So
and let's say my thumb is the player, as you move around, the player stays, this square inside moves around
right.
to make sure this is the player who's in the center. As you're moving the player to the left, they'll just move the entire screen.
Yeah. So exactly.
So this background here is the monitor. This is the inside level that we drew.
It's-
Player will always be in the middle. This guy just moves around him.
Yeah, we have this, we have a camera, quote unquote, following the player, and then we take what the camera can see and draw that to the screen, instead of always having the screen be locked in like one corner and the player can just walk away. That's what's happening. And since the camera is following the player, the actual mouse coordinates in the world are going to be relative to the player. But we don't want them to be relative to the player, we want them to be relative to the screen. So it's about doing a conversion for what we can see versus what's actually inside the world. Because let's say players here, mouse cursor is right here. This position in the world is different from this position in the world. But relative to the camera, they're the same position. Does that make sense? So since they're, this is the whole world, so if you consider the position in the world, this position here is I don't know, 500, 500. But then this position in the world is further than 500, let's say 600, 700. It's much further, but relative to the screen, relative to the player, it's the same position, right? So we have to have some way of converting between where it's actually touching the world and where it actually is on our monitor.
Yeah.
And since they're different, we have to have some way of converting to make sure everything stays linked up. So that, when we click here, our player moves down here and we click here, the world doesn't change up here. Where, the real relative position is.
I think the paper idea is still good. I'm pretty sure I'm going to
The paper idea is good,
So-
the problem is trying to demonstrate this on a board is hard.
Right. So once again, let me do it quick.
Yeah.
Let's see here. I'm going to draw a square.
We're trying to re-explain the same thing 10 times because it's really hard.
There's got to be a good way to do it, obviously. This square is your monitor, yeah? This is the inside the game, your level, right? And then your player is always going to be here at the very middle, right? As you move to the right, the inside the walls, these are your walls that your player can't cross, right?
Yeah, that makes
So as you start moving to the right, this is just going to move. It's going to move the whole level to the right. And when you hit the wall here, right? How do you know where this wall is? right? Because we know like this guy is, we'll say 500 by 500.
Yeah.
When this starts, you go, okay, well, I'm here, and then this is 250 to the right. Well, this 250, where is that on the monitor? Right? If we go, this is what? 1920, 1080, right? So this cut in half, this cut in half. Right? And then in here will be, this will be 500 by 500. Right? So right now, you know where the edge of the level is. You go, okay. But what if I move this guy over? Right? We're going to move him over 250 to the right. To the left. There you go. This has shifted. So once again, you have to calculate where the wall is compared to where the screen is.
That's as good of an explanation.
I think it's not as good as it. There's a good way to do it. I'm positive
The good way to do it is to.
It's a good way, just for me to understand it better myself before it's to explain it.
Either way, let's talk about.
There's a better way to do it. I'm
Let's talk
positive.
about Alex's project.
Yeah.
All right, so we're gonna kind of like step away from like Visual Studio and C++ and kind of dumb it down a little bit with JavaScript. So there's a site called Vue.js. Basically, it's lets you do JavaScript on a browser instead of on like code editor like your code. So this is just an empty project, and basically, just to break it down, there's two functions: setup and draw. So setup is like it just draws whatever you put in here one time, and then draw will repeat this. It's it draws an infinite loop basically, and then kind of like with the SFML, you can wipe the screen and then create a picture and then move it and do whatever. But way back in
Yeah, so JavaScript, just to explain, re-explain in different words. JavaScript does the exact same thing that we've been doing in our SFML, except instead of having it all be in main and we run the setup and then have a loop for the code, this one has a function for the setup and a function for the main code, and that main code function is run. So same idea, just slightly different construction.
yeah. So okay. So this is my project from like AP Computer Science Principles in high school. So you can see the function setup right here, and then the function draw is a lot bigger. But it's basically a game. I'll just play it so you guys get the gist of it. So, yeah, well, there are the instructions. So basically when you hit the black orbs, you lose like saturation, and then when you get the colored orbs, you get more saturation.
Yeah, she's a computer. Yeah.
Promising computer scientist.
She's in.
The hitboxes are a little off, but it works well enough. And then we can just die here, and then if you collect enough of the orbs, then we get a second chance. And press space, continue, play again. And then if you die again, that's it. And yeah, keep track of your score and how many like colored orbs you get. You can just keep going, and just get the highest score you want. I didn't really track, what's the highest score you got from all of your runs, but yeah, this is basically it. To be quite honest with you, the organization in there is pretty awful. In SFML, I think they did a good job at keeping things really organized and leaving comments everywhere. But as you can see, I don't have comments
I think
anywhere.
you were in high school, right?
Yeah, I was like
You're
fiddling
Oh,
around.
so they're doing comments because they're supposed to.
Yeah, I mean, that's the thing is SFML could be disorganized. It's just it's a textbook. It's given to us in a very organized format. This is real coloring.
This is it, baby.
This is an app that you're trying to put on the App Store.
I mean, yeah, I think there's an option for that.
I've seen worse.
Steam Greenlight or whatever it's called.
Yeah, but getting into the.
Is this how we're gonna raise funds?
Yeah, let's make some apps.
It's
Come
not.
on, dude.
Well, just to compare this to C++, I guess.
Are you like manually setting the colors? Is that what those are?
Yeah, these are colors.
RGB.
And then I forgot what the heck this is, but
VR.
these are just like a secondary RGB.
25, it's like you're
3Ds.
slightly changing. Maybe it's a gradient or something?
Maybe. I don't quite remember because like yellow obviously isn't red, green, and blue, so it's a combination.
It looks like whatever your selections are, looks like the opposite of what the main color is. So for green, you have red and blue. For
Oh, yeah, yeah.
green and blue, you have red. So it's like kind of trying to keep track of opposite colors. So it's like maybe is somewhere in your game where you keep just like at any point are you like drawing reversed colors? Like you have the screen yellow and one of the dots be an opposite. That's what it looks like to me.
I don't think so. I don't remember what happened. This is why you should leave comments, but.
You know what it almost
Keep
looks
your
like?
eyes peeled.
Guitar Hero.
Wherever we see the VR, VG, and VB, that's,
Yeah.
so we see, whatever this is drawing, I see R and VR and G and VG and VB.
Yeah, this is, I think this is the road. The road is actually a bunch of lines,
250,
and they like have.
125 lines to the road.
Yeah, so like you can set the stroke weight of the line, so how thick the line is.
Okay.
RGS, and
There you
then
go.
when you do it, like I don't know if you can see it, but at the edges, like they slightly vary in length.
The wobbliness.
Yeah, it just like to simulate motion or something. And,
So I wonder, I'm not seeing opposite colors. Maybe
yeah,
it's-
I don't know what happened.
I'm curious, so hold on, it's R times 1/2, sorry, R times I over 2, plus VR times random 25. That's what you're setting the color to. Red times I over 2. So that is, this is for drawing the road, I believe. And I think you're drawing it either top to bottom or bottom to top.
So you select the color randomly in the beginning, I guess, and that's why you're doing random times whatever, because that's just the color.
So, I believe what this code that we're looking at is accomplishing is the color of the road and how it has a gradient going from the brightest at the bottom to the darkest at the top.
Yeah.
And then it seems there's a little bit of randomness in there so that the color itself, not like the actual like wobbliness, but the color itself fluctuates random. That's what I'm getting from this.
Yeah. I put a lot of random details in there.
That's what makes the road look interesting.
Yeah,
Play
having
it again.
fun.
I want to take another closer look at it. Because I think I'm understanding a little bit. The colors don't look like they.
I like this darker at the top. It is a gradient.
But that is it's just a plain gradient.
How are you drawing the line? Are they left to right then? And then, because I was assuming it was some sort of triangle, but I think the line is drawn left to right. And at some point, you're deciding where the black parts are.
So what we can do to make it a bit more obvious what VR and GMV are doing, right now you have them multiplied by random 25. If you kept that up to like random 255, that would make whatever it's doing way more obvious.
Program going on today?
We could try that.
Yeah.
Oh, it looks like it's across, the lines across the screen because.
Yeah, they're drawn fully across, and then at some point, you're deciding to fill them black. So, I'm assuming you're drawing the whole string top to bottom right there, and then there's another for loop that is doing the road. You guys- Yeah, so I think what that part is probably filling the entire screen, and then the edges side is somewhere else.
I submitted the
So
actual.
you have another set of pieces up, so I think they're gonna be doing some stuff with integration fee and so ladies scout.
I sent it a couple days ago.
The last three
No, I
rows
don't know, put it last night.
or two rows in the back or crowd
Nice.
for spectators.
Sure. Well, let's give it a couple more minutes and we'll go in. When's the next round?
I'm not sure.
Double check.
I think they're gonna do competitive mode. Right now they're just like doing a test.
Okay.
Yeah.
So I thought it was gonna start competitive, but
The weekend now.
I've never.
What's
We
integration?
don't want to catch it.
Huh?
So,
Math challenge.
yeah, so the D10 stuff.
It's some sort of formula you just solve, right?
Yeah, I didn't solve one.
Currently on the.
I guess I always.
Alex, you've been hiding this from us this whole time.
Yeah.
And we could have been,
It could be your AI thing,
like this,
we
we
could
could
have
have
been
been,
this every Friday.
yeah, we could have been submitting apps into the apps for a problem.
How do we know if it's,
I'm kind of focused on reserve.
Okay,
it's random? So I guess the position of those circles. Funding always, war, you can always.
You gotta get on it.
So if you die again, it doesn't matter how much score you have.
Could have,
If you die, you die.
could have refocused you.
If you have a high enough score, then you
Does it get harder as the score goes up?
I don't think so. I don't think I did that.
So it's constant, just emoji.
Yeah.
Color or
Just
buy
keep
good.
going.
That's one.
How about I can also
There's
stuff
some,
like a lab, like stuff
that
like the working
circles are so close together that's unsolvable, so that's like no way you could just say, okay.
Yeah, this is the chance where that you just get trapped by unlucky.
Circles are randomly generated, right? They randomly pick a line and travel down.
Probably gonna miss name.
How are their like angles calculated? They're like a random.
I don't know how this like stuck on that for like the longest time. I don't even remember.
Because it says circle right there.
I think it's obstacle.
Obstacle, D equals true, circle, right there, direction, D divided by 100. Obstacle travel, okay, so obstacle travel is D times direction, D divided by 100. So that's where the circle goes. I'm assuming there's a set length. What is D? Yeah, like you use D of 1. Obstacle travel D, let D equal 0. Okay, so it does it up to 9. D is distance?
I think it's the number of
Number of obstacles, not the obstacle travel D equals 0. Direction D equals random, minus 100 to 1,000, obstacle chance D random to 100, if obstacle D is greater than 9, and obstacle chance D is less than 100, still 1, go 1 to 0,
Alright, I'll do it.
plus 5. So I think this loop takes them through, makes the circles travel down the path.
No, I'm not. Why not? Because I'm not a scientist.
When
you're not? No way. Really?
And then their direction randomly decided,
Yeah.
right?
Is an obstacle travel?
I remember last year,
Obstacle chance. What's obstacle?
I think obstacle is, if you look like lower down, I think it's like, obstacle travel is how far they're traveling, see how it's travel distance times direction.
It was
And I think these keep increment,
they registered for a 1 minute walking class.
right? So it's, circle, 400 plus obstacle travel times direction. There's two travel.
So hold on, this whole thing is inside of an if statement.
This is inside a loop.
Yeah, but the whole thing is inside of obstacle chance greater than or equal to 99, that should be less than. So as long as obstacle chance is greater than or equal to 99, and less than or equal to 100.
Yeah, that's like, so it doesn't always do the
Right. So obstacle chance is the chance that that obstacle will appear. It's randomly generated between 0 and 100, let's say 100. So it's randomly generated between 0 and 100, but only if it's 99 or 100. So it's, in other words, 2 out of 100 chance of 100. So 1 out of 50 chance of 100 for that obstacle. Maybe we go
Want to
through
turn
it.
it?
Just to introduce the chat. So maybe, so if it rolls between 99 and 100, this whole if statement happens. It fills with white, so this is definitely drawing the obstacles, right? They're white circle.
The outline.
Yeah, they're white outlines of black circles. So, fill white, stroke weight, and travel. Obstacle travel D gets obstacle travel D plus 5
So it's moving each individual obstacle by 5.
by 5. So they go 5 further, quote unquote, down the path.
Yeah.
Then, if obstacle travel D is true, no, just if obstacle D is true. So I guess that's whether or not the obstacle is
Yeah, if it's
currently in
currently,
existence.
just like with the bee, if the bee was alive and Essex,
Yes.
then we could do whatever.
So
And update.
then what you're doing is you're drawing. So if it is true, you draw a circle, then change the color to black, draw another circle. So that's where you're actually drawing it.
Okay, so you're
It's in
drawing
position.
a circle filled with black and then, so one of them, so originally it's filled white.
Yeah, so he's drawing a white circle and then drawing a slightly smaller black circle on top
Got
of
it, that makes
So
sense.
it looks
That's how
like,
he's doing the rim effect.
exactly, that's why it looks like,
It's 2 circles.
yeah, it's actually just 2 circles drawn on top.
Nice, just like we did the B with the smaller B underneath for collision.
Exactly. So, and then.
Same idea, look at you were ahead of the curve.
The
Crazy.
math there is what's determining where it's drawing the circle. So obstacle travel D times direction D divided by 100, comma, obstacle travel D, comma, obstacle travel D divided by 5 plus 10. I don't remember the parameters for the circle function.
Yeah, we can go to reference and then go to.
Yeah.
Looks like it's X, Y, then radius.
Yeah, X, Y.
Probably.
D is the.
Okay. So we get our X position, our Y position.
And
So-
it's blown out from there.
So yeah, so the X position is 400 plus whatever its travel modifier is times its direction modifier divided by 100. Obstacle travel D is the Y, that second one. So what that actual obstacle travel D, that's just the Y position of the circle. And then the actual X coordinate, so how it diverges horizontally, and also its diameter, the last parameter, change based on how far down the screen it is. So, in other words, it's just drawing the circle, obstacle travel D goes up, it goes down by 5 every frame. How much it diverges is left and right, as well as how big it's being drawn is done with math.
Yeah.
That box is just, a box of the option.
Oh yeah, I also have hitbox. I don't think I needed this. I think I could have just used the.
And which part is divergent?
It's the first one.
The first part.
400 plus obstacle travel D times direction D divided by 100. Whatever that direction is.
So it's the random, right? Direction is either randomly selected between negative 100 and 100.
Well, there you go.
And that's what's giving it the angle that it's traveling.
Yeah. So presumably, negative 100 would be far left and negative.
Yeah,
plus
so
100
it'll be more to, like, I guess the screen is split down the middle.
Presumably.
So So 0 is the middle of the screen,
No,
negative
I don't think it's
left,
actually, I think
positive
I
right.
probably moved something else. And then.
So,
400 is half the screen.
yes.
And then,
And so you're-
you go negative or positive.
Yeah, so then you add either a negative or positive value. Yeah.
Oh my goodness.
Adding plus actually down.
Oh, yeah, it goes, the top left corner is 0, 0, and then you add X to go right, and then add Y to go down. Oh, so it goes,
Okay.
yeah, I think it's similar with SFML, somewhat.
Well, same thing, if top left is 0, 0.
I'm understanding.
Yeah. Something interesting, the actual, what is it, the cube thing that I use is not actually a cube, it's just a bunch of squares layered on top of each other.
You're
That-
faking it.
Yeah, pseudo 3D. How would one-
It's like how we can draw cubes on the board. It's not actually a cube. It's-
Yeah. And then, so this is basically SML.
Yeah.
Key is down, 37 is like mapped to, what is it?
It's gotta be left.
Yeah.
Left and
then-
right.
Left and right. Yeah, this is just a bunch of text, functions. This is the swan thing. Yeah. Checking if it's got hit, checking if it collects the color orb, and doing whatever. I think this manages the second chance, like if you get a second life or not. Let's see. What did I make the? Yeah, so the square is where I create, it's a for loop. So in this for loop, I create the array of, not the array, but multiple squares that are layered on top of each other. And then all this math to figure out where to put each square so that it simulates a cube when you move.
So it's just a bunch of squares,
It's just a bunch of squares.
Yeah, so it's like drawing a cube.
a bunch of times.
It's like
So
drawing a
you
cube
can
by
see
turning
here,
it into
just a bunch of
slices of squares.
There
You
it
see
is,
that?
yeah. It's like a stack of cheese.
Exactly.
Slightly.
That's how you're creating a cube, is by making stacks of
Very
individual
cool.
cheese squares.
So, okay, so let me ask this, so like, is there a way to actually do the cube without stacking?
I think,
As a three-dimensional?
Maybe, but the JavaScript canvas is really not designed for 3D.
this one has,
So maybe,
they have a box, but I tried fiddling around. I don't know how to move it. You could maybe figure it out.
the math is gonna be harder than necessary because it's trying to do 3D math in a 2D plane. It's not, it's a canvas, it's a 2D drawing area, it's not meant for 3D, so you have to think it in some way.
And
Yeah,
that's
it's pretty
that's-
clever.
Is
Right,
that
I
across
didn't
the
realize that
board,
was
just
just
like
kind of-
JavaScript in general?
JavaScript canvases.
JavaScript canvas?
The canvas object in JavaScript does 2D drawings.
Okay.
It doesn't do any modeling, it's literally just drawing, just like our SFML. There's no models under the hood. So if you want a cube, you have to figure out mathematically what that would look like on a 2D
We
plane.
can do like pseudo 3D in SFML using the raycasting thing that.
Yeah, I think, yeah, SFML is
Which is what I'm
a little bit
working
more
towards.
3D. SFML's got like,
See the million.
Well, it's using OpenGL or whatever.
I mean, this is basically all the same library stuff as that one project I have with bubbles. It's more or less similar, just, I do things a bit different.
That was his whole project, though.
Mine's not a game, but it's just.
That's pretty interesting.
But is the transition
That's quite good.
Then again,
I didn't even know which guy it was.
Is it just part of
He just showed all the ones at the end of class.
this library?
so, no, the canvas is just part of JavaScript. So, yeah, what this site, it looks like this site is doing is it's letting you not have to do the HTML.
Yeah.
In the HTML, you just say, make my HTML page and put canvas right in the middle. It's technically an HTML object, and then in JavaScript you can mess with its functionality. This, what is it, P5JS, this is doing the HTML part for you and just giving you the canvas to mess with.
So in comparison, because I'm not too familiar with JavaScript, in comparison to C++, JavaScript is not is it object oriented? No, it's not object.
You can make objects in a lot of the powerful languages, but it is not designed to be object oriented. So you can, like, there's a way around it, but
It's
it's
like a library, or
not only, you just gotta be really,
are you just like
Tricky.
making objects your way in the right data structures or something?
if we pull up the project that I've shown off a few times, the one with the bubbles going down the
The
street,
bubble.
it is object oriented in JavaScript. You really fake it in JavaScript. C++ is object oriented. Java is very object oriented. Python can be object oriented. JavaScript really is not, but it's such a powerful paradigm that people have found ways to do object oriented design in every language, and that includes JavaScript. So can be done, would not call it ideal. If you're like, I want to make an object-oriented program, and the whole point is being object-oriented, what you should do is say, why should I not use Java? Like, Python's not a terrible choice. C++ is actually a great choice for object-oriented design. But like, why are you not using those big three for object-oriented programs? If you need a good reason why not. JavaScript, you need a good reason why it has to be JavaScript for object-oriented design.
To be a rebel.
We used to not have classes, but then recently they added classes.
Exactly. It's such a powerful paradigm that basically every language, except for the ones that are trying to hipster and cool, they basically all adopted in some way. But that doesn't mean they were meant for it.
I'm assuming it's like old legacy stuff that doesn't have objects, so you can't really introduce objects to it anymore. You're just gonna have to keep working with what you have,
Kind of.
right? You know, like, oh, we have this JavaScript program, doesn't use objects. You're like, well, let's add objects. It's like, no, we're just gonna introduce it the way it is and add it.
Yeah, that's the thing, is it's really, well, here's the thing, the whole thing is not really object-oriented, and yet, even this program, if you look at all the function usage, it's almost object. We just don't have any true objects.
When you did the algorithm for that program, so why did you pick JavaScript?
Because it was quick and easy, and I knew I wanted to be able to display, and I didn't know about SFML at the time, and I know that in all the other languages, you have to jump through hoops to get something to draw. Like
Yeah.
C++, SFML is the only good way.
Well, you still have to do that linking, right?
Yeah, and Java, I guess you use GUIs, but they're really not meant for it. Python's probably the best, but even then, you got to import libraries. JavaScript, make a canvas, draw it done. That's what I want.
Yeah, and I think you just write it in the browser.
Exactly,
And
and it
if
just
you use
runs-
SFML, you have to make.
I mean,
it-
Canvas is in
Exactly.
HTML, right? So you can use
Exactly.
You can use all this into your HTML.
That's why I chose it for mine, because when I made that, I literally did was like, I want to try and quickly code up just some very basic genetic algorithm thing. And so that I wanted to be fast and easy, and the hardest part for me was gonna be displaying it. And I knew I could just make a canvas and draw circles on it. And so it's like, that's so easy, I don't have to import anything. I literally made the whole thing in Notepad. It's just like, it was, that's why I chose that.
Do you remember MySpace?
Yeah.
I mean, I remember it, I didn't really engage.
Oh, yeah. You didn't-
I am not a social media person. I am still not a social media person.
Yeah, it took me a while to get on there. I was
MySpace.
not. I'm still not either.
I mean,
You were late to the blunt
I
doctor quizzes or whatever?
I use Discord, and that is the closest you'll get me to any social media. I don't got a Twitter or an X, I don't got a Facebook, I don't got a nothing. I don't got an Instagram.
You're off the
Don't-
grid.
Yeah, don't ask me about
You're
that.
off the grid.
I'm-
He's
I-
not off the grid, he's got a
Yeah,
Discord.
yeah.
No presence.
I've got a LinkedIn. But like that's I've got a GitHub, but that's it. I'm not a social media person. And even then, MySpace was just a little before my time, just a little, not very much, but just
How
a
old are
little.
you?
Almost 30.
I guess
It was the same time.
because it was
Yeah, the same time.
Well, it was around then, but I was like in middle school. I don't know.
Yeah, that was
I mean, I'm not a
prime.
social media person. I was never interested, especially in middle school. I play video games.
I feel like,
Nice.
because I'm 36 and it was like, I always felt like it was a little late to the game there too.
Yeah, it's like I didn't know what a social media was until high school. They existed, I just didn't know or care. I played Mario.
It's like HTML.
The internet, yeah, I was HTML. The internet was a little different then. It wasn't.
Things were easier.
MySpace just lets you modify the HTML of your page. So they just gave you your page, the code's already written, and you just make small changes.
Yeah.
You just paste in a music player, and it would blast whatever song you selected.
That's, I remember that happening to people.
It was a better.
Max volume.
Better.
You guys remember when web pages would just blast max volume music when you loaded them up?
You can just do it.
I mean, nowadays you can get like ads, but back then it was just like whoever's favorite song it was, just max
People
volume.
would pick insane backgrounds. You could do the entire background just like a moving,
Yeah.
like weird static. And you can't read anything.
Yeah, you can still do that. I mean, you can still do that, you just gotta do it yourself. And not
Yeah, but like imagine you do your Facebook page, you know, your front facing Facebook page, you open it, you can't read any of the text because it's like white text on a white background.
Exactly.
You're like, no, you don't understand, this is me, this shows who I am.
Power is in your
What
hands.
object are you with?
Yeah, the background were just crazy, they were nuts.
Yeah, just pick a PNG and just type it. That's your background.
Should we go check out the Teco feed?
I'm gonna say here.
Yeah, that's the rules, you can't leave your drafts.
Yeah, basically. As long as somebody's here, I'm gonna say here.
Well,
How do we turn this into how do we turn this game into a massive multiplayer shooter? Where,
Nice. Okay, well, what you need to do is probably pick up Quake
Yeah.
and look up how they did all that.
I mean, I don't know about shooter, but massive multiplayer, I would love to see just 1,000 of those squares all at the same time, trying to dodge all the circles. That'd be fun.
and like if they have contact with each other, they just bounce each other off.
You can only fit like 10 of them. And somebody's gonna lose because like you can't dodge.
How would you, can you only put one cube or one square, or would you be able to do a replica of that?
if this square is
You
one,
you could very easily draw another square. The hard part is giving control to another person.
yeah.
Because like this is, again, it's not like this object that we're tapping into control of. This is just like player has a position and just draw the square on that position. Multiplayer is the hard part.
Well, you could add another square and just give it different keys to it.
Yeah.
Yeah, you could.
Done deal.
Split keyboard game?
Yeah,
There you
could be
go.
done.
You take controller inputs.
Yeah, learn how to do controller inputs. Basically, I mean, it's,
Well, you can just bind the controller to keys on the keyboard.
that's one way.
You're back to where you are. There you go.
Also, it was like messing around with some 3D stuff. So this is really short, just 22 lines, and then it just rotating things with lighting.
Oh.
And just like that, we're just like basically Pixar right here.
Yeah.
So,
Is it
Toy
going?
Story.
Is it going? They're playing.
Chuck your pizza, go try with people.
I'll check it out. That's crazy.
we're in an arcade and we're buying.
They haven't started
They're
it.
competitives. They're ones that start.
I don't know, they're still.
I wanted to see the competitive games.
I want to see the competitive.
So you have to put this, you have to tell the.
I don't really know how this works. You can like turn it around, it automatically rotates and moves it in. So I really don't.
Is that just built into this game, or is that something in your code?
Uses web.
Yeah, if you're interested,
I don't know
to
anything
do it
about
every
like
Friday,
SEO,
same time, 3
Yeah,
to 5.
I'm not big on it.
And Gideon's our advisor.
Professor, is this an object? Or, I don't know what the curly braces exactly are. I
It's
just know
still
it's
grading. It's still grading.
It's an orbital control 111, single protection.
You just go in there and start shaking random people's hands and just walk out with like a box of pizza.
Who's
that guy?
A whole lot.
This, it looks like a stick.
Did you just use some sort of formula?
just came in and said hi to everyone and walked out with a box of pizza.
Really?
The orbital control is like, so if I change this Okay.
Is he even a participant?
It'll only rotate one axis.
Yeah.
Wait.
I think
I
that
think
maybe-
this doesn't do anything actually. I tried it earlier.
Wait,
Yeah, sorry,
but
my
can
bad.
you not drag it around? Is that what was controlling the drag? Yeah, that's what was controlling your mouse movement.
Yeah.
So they're doing all the hard work for you. They're just, you call the function and the web page does it for you. I don't know what that is. So that sounds good.
And then rotate is what's pushing it.
Yeah.
And then I select the axis count, it's a global variable. And then I make a torus in the box. And they both rotate.
computer science?
I don't know how you would.
So the box is the actual cube?
Yeah, the box is the cube.
So they do have 3D drawing functions. But it's still just math.
So this is it,
And then
Can
there's
you
a.
double click and it'll tell you how the box is made, or?
I don't think it's just.
The box is a function call, right?
He's on the web interface.
Oh, yeah, if you want, just, this is the box, look into it.
Okay, here's the code.
You know.
I don't know how to look into like exactly what it's called.
I think right there at the bottom, is that not the code?
No, this
That's
is
an
just
example.
like.
Oh, okay.
indentation.
Yeah, web
Yeah.
browser.
This is
They're all in
Touch
the.
API, there.
Parameters.
So it has the parameters for how to create a box.
Yes.
And it doesn't explain much, does it?
We have a big thing coming up next Friday.
Who did they give you the code?
Speakers from Microsoft.
What code?
That's basically the 2D science. And there's also this directional lighting thing, which we're going to take
Yeah. So those, your boxes and stuff aren't actually rotating. You're rotating the screen, and you can tell because of the lighting. Like, the lighting doesn't change on those objects.
Oh, no, I think the box is rotating. If you turn back the orbit control, we can rotate it so that we can see the lighter side.
Oh, you kept the 0 sign.
Oh, shoot.
If you want to change the back.
But yeah, it's, so this is kind of dark, but we can turn it,
Even apps have to be
wall,
secure.
and then it's brighter because it works into the same direction as the lighting. Right here it's more blue, but on the other side it's dark.
Right.
Well, I think they just, some sides, they're
Yeah, there's some, as he's rotating the screen, the light rotates. So, like,
Every semester.
the light is
Semester.
fixed in the image, and as he's rotating it, the light is rotating with him. So the same sides of the boxes will always be bright. It's not like he rotates the box and suddenly the underside is bright and the top side is dark. No, the light's rotating with the box.
So, yeah, so the object is moving, and then we can, the light is fixed, and then we can move the camera to see what's happening.
We're rotating everything, including the light source.
You do this, and then you have the, object that is moving.
Yeah, and we're here Friday, if you in the same exact building,
Cat.
see what's going on.
that.
Yeah. I mean, I haven't really messed around with this too much.
Pretty cool. So, note this one down. T5JS.
Teacher gave it to us in high school.
I would give it to my class.
Same thing.
That's really convenient, actually. I mean,
Yeah, always on the lookout for good programming tools.
I think you can integrate this into. You could probably integrate this into a web page.
Yeah.
Same thing with me, I think,
Just spin it. That's how they do it, right?
I don't need to stay.
There are any websites that use 3D optics?
Yeah,
Like, that's great.
Read.js. It's like a JavaScript library or something.
Are there an actual web page?
I don't know where, like, I just find a random page. Let's just do this. website. Is there a link?
Whatever you do. Well, I guess you do that.
Yeah, this is a web page, and then
What's
they
the
use
one?
3DJS to like animate all this 3D stuff.
I like it, that's good.
And then when I scroll, it moves.
The rendering on that must be insane.
Yeah.
You make it?
No, this is just like just a showcase of like what you can do with like 3D stuff. Yeah, this is not P5JS. This is 3JS.
Like that's in Canvas with the WebGL?
What?
Is that in Canvas with the WebGL?
I have no idea how this stuff happens. I've just kind of seen it around.
Oh, you use the marker right there, right? It'll draw.
Looks like it's interactive,
It's right, like, it's not just an image that cycles. It's actually being generated.
seems like it.
Yeah, it looks like they're using WebGL.
Oh,
Like,
what?
little- Oh.
That is insane.
Yeah. But this is just like, yeah, JavaScript and 3D stuff. Pretty cool.
The power of JavaScript.
So all we gotta do is just put SCC Programming Club, like, copyright watermark on there, and we can
Yeah,
like.
just have ChatGPT reverse engineer it.
Oh my God.
And then you'll be like, yeah, I made this.
I'm getting it.
You made this? You're like, yeah, I made it.
I could inspect, use the inspect tool.
Oh yeah,
It's gonna be big.
it would probably be nonsense.
And this one might be a bit much for it to be inspect tool.
I didn't do it. I believe in ChatGPT.
Can we run it on the ThinkPad?
Right click on it. There you go.
Run it on the ThinkPad.
That's in Canvas.
That's just the HTML.
Yeah, I have a debate coming up for cybersecurity and AI.
Well, can't you just download the whole thing? Right? Will it run offsite?
Probably, unless it's accessing things that aren't.
It's my-
Because again, this is just the HTML, this isn't JavaScript itself.
Might be calling out.
Yeah,
Yeah.
website's regular.
It's to,
So we could do this with .js.
AI.
It might be if you click on it. Show the script.js.
Oh, God, well, obviously, I'm for it.
Don't need us. Are you?
I mean, that's the thing is, with it, you know, you spend all this time making a website like this, you don't want someone to just come along, inspect element, copy and paste everything, and say, I did this. It is a bit hard.
That's legit with ChatGPT.
I did this.
I did this. Studio Ghibli.
Anything that has a profit margin.
Yeah, I mean, that's pretty much all I got.
It's cool though.
I mean, it's only
Is there another straight JavaScript other than the fact that it's just popular?
I mean, it is the language that we use for web stuff.
Yeah.
I mean, the fact that we say, you know, it's HTML, JavaScript, and CSS. It's not HTML, CSS, and a programming language of your choice. It's like the fact that it's built for web browsers. The language itself is meant to run on web browsers. All the libraries and stuff that comes in are meant to run on web browsers.
If it runs in the web browser, it is cross-platform.
Yeah.
It'll run on anything.
So the JavaScript is, you know, powerful and popular for a reason. It's just, you know, if you're doing stuff with web browsers, it's the go-to. If you're not doing stuff with web browsers, why are you using JavaScript?
No, that's the thing, it'll run on your phone, it'll run on your Mac, it'll run on a computer, it'll
Yes.
run on an Xbox, it'll run on anything that can run a browser, JavaScript will run
Yeah.
on it, right? That's it. So it is, I want to think, the most cross-platform.
And since it runs on a browser, you only need a browser to run it.
Yeah.
You don't need Visual Studio or Python or any library.
You want to develop games for the Nintendo Switch, dude? If you run in the browser, you can run on the Switch.
It doesn't have to.
Does it? I thought they had like a, I mean,
Not
Google
anymore.
it in the browser.
Not anymore.
Nintendo blocked it?
Yeah, nobody used it, so they stopped supporting it.
Who would?
Nobody's using their Switch to browse the internet.
That's great. Well, I think they're just packaging it into apps that. Like, it's Instagram runs on Twitch or something. That's just like a browser kind of, no? I
I don't know the games. I don't know the
You don't check Instagram on your Twitch?
No. I don't have Instagram.
Or your Discord? Okay, well, this Discord run on Twitch now? It's crazy, dude. It's good.
Getting replaced soon.
Right, no, they're building Discord into it, that's why they didn't have it.
Exactly.
Okay, got it, very clever,
Yeah,
Nintendo.
Nintendo is the kings of the West.
Well, it's pretty clever of them not to give Discord on the Switch, so they can have their own Discord,
Yeah.
instead of giving up market share.
Yeah.
Never give up market share, that's the number way to go.
gosh, okay.
Let's see if it works.
Never give up market
I
share.
mean, you're right.
Surely, eventually.
We'll see. We'll see if it works.
Unfortunately-
There's already plenty.
You're for it.
We'll see. We'll see if it works.
Eh. No, you gotta have voice in it, no way. Like, the future is voice. Right,
Yeah. The future is voice, meanwhile, the game consoles from 10 years ago.
Right, well, that was what's so crazy about the 360 is that, like, yeah, you can,
Exactly.
everybody can play games, you can play games, but they're connected by the
Exactly. So, again, Nintendo is the kings. Nintendo are the kings of reinventing the wheel. It's like, we've got voice chats. Like, you are 20 years now.
Well, you know, they're on time.